Hello. In this episode, I'll be going through the answers to these questions, starting with Task A. For a start, you're asked, what is the electric force between the charges? So use your electric force equation. F equals this constant, 1 over 4 pi epsilon naught, Q1, Q2 over R squared. You can substitute your values in, that whole fraction, 9 times 10 to the 9, R, 0.2, Q1 and Q2 are 10 times 10 to the minus 6 and 5 times 10 to the minus 6 coulombs respectively. Plonk it in, shove it in your calculator, you should get the force 11.25 newtons. The next part of the question asks, what is the electric potential energy of the system? Well, use your potential energy equation. 1 over 4 pi epsilon naught, Q1, Q2 over R. Again, Q1 and Q2, 5 and 10 microcoulombs respectively. R is still 0.2. That fraction is still worth 9 times 10 to the 9. You should get 2.25 joules. Finally, what is the electric field midway between the charges? Right. Well, there's your electric field equation. You know 1 over 4 pi epsilon naught is 9 times 10 to the 9. Put in 10 microcoulombs for a start, 0.1 for R, 9 times 10 to the 6 newtons per coulomb. That away. That is telling you the electric field due to that charge at the midway point, the 10 microcoulomb charge. So I've got the 10 microcoulombs there. Then do the same thing again, but with the 5 microcoulomb charge. It is also 0.1 meters away from the center. You should get 4.5 times 10 to the 6 newtons per coulomb, but this time that away. The electric fields come out of positive charges, so in the centre they are in opposite directions, and these are combined as vectors. So overall the resultant is that way. B. Same questions, same values, other than that's minus 5 microcoulombs. So this might be quite quick to go through this one. Part A for that, very similar to part A for task A. Put all the values in, no problems, but it's a minus 5 there. That just comes out as minus 11.25 newtons. Whether it's positive or negative, it doesn't tell you anything about the direction. This just means it's attractive because the charges are opposite signs. B, exactly the same idea as on the previous question, the potential energy equation, 1 over 4 pi epsilon naught, Q1, Q2 over R. But again, this time it's minus 2.25 joules because one of the charges is negative. And part C, again, exactly the same idea. 1 over 4 pi epsilon naught, Q over R squared. You should find that as the resultant value. I forgot to write my squareds in, but I did do it. It's 13.5 times 10 to the 6 newtons per coulomb, because this time they're in the same direction, because that is now a negative. Notice I haven't got a negative there. Add a minus, making it a positive, adding them together. I didn't have to take them away because they're in opposite directions. I'm adding them because they're in the same direction now. 13.5 times 10 to the 6 newtons per coulomb. C. Right, first bit's asking, what is the electric field at P? So a point 0.1 metres to the right of the right-hand charge. Right, you've got your 1 over 4 pi epsilon naught, Q1 over R squared. So that will be due to this charge at that point. And then I've got, again, KQ over R squared, but I'm 0.1 metres away from that one. This time it's a negative, so I've got my negative there. I'm not really interested whether it's positive or negative. I really look at the magnitudes of these things. And I know the field is coming out of this charge, so it's heading towards the right due to this charge, and it's going into this charge, so it's heading left due to this charge. So I'm not really bothered about the sign of the charge. I need to think about the magnitude of the field and the direction. This one is a field to the right, this one is a field to the left, so I will subtract this from that. Well, you might get minus 3.5 times 10 to the 6. I suppose I did, but I just said that means 3.5 times 10 to the 6 newtons per coulomb that way. Finally, that question asks, what is the electric potential at P? Should be a bit easier than that one. Your electric potential equation, 1 over 4 pi epsilon naught, Q over R. So we'll work it out for the left-hand charge, we'll work it out for the right-hand charge, and then just add them together. Now remember, it is a minus 5, so I've took it away. Minus 1.5 times 10 to the 5 joules per coulomb, or volts. D. So this, well, the charge is in exactly the same place, it's just again a different question about them. Is there a point apart from infinity where the net electric field is 0? So remember, if you go to infinity, you're an infinite distance away, there is no electric field, there's no potential, there'd be no force between the charges. Is there anywhere other than that though, where the field is 0? If there is, where? Well, hopefully you've spotted the answer is yes. All we would need for the fields to cancel out is for them to be of the same magnitude but the opposite direction. Now, for the magnitudes to be the same, we must be closer to the smaller charge. That's telling me the point must be here somewhere over to the right. There's your 10 microcoulombs, there's your 5 microcoulombs. Okay. Right. So, that is a minus, but that's fine. So look, notice they are on opposite sides of an equation here, so if this was on the other side it would be a minus. I've put it over to the side so it has become a positive, that's okay. All I've done here is 1 over 4 pi epsilon naught Q1 over R squared, so I've got 0.2 and another x meters to this point here, and I've done 9 times 10 to the 9, so that's 1 over 4 pi epsilon naught Q over R, which is x here, the unknown. The magnitudes of those two fields must be the same for them to cancel out. So remember, this is positive, so the field is coming out of it. This is negative, the field's going into it. So over here, they are in opposite directions. That's heading this way. This one's heading that way. They would cancel out. Now, we just need to rearrange that and solve for x. Bish bash bosh. You've got your answer. Now, obviously, the 9 times 10 to the 9 cancels each side, so does the 10 to the minus 6. You've got a 10 and a 5. You can divide through by the 5 and get a 2 appearing somewhere. I've got rid of the first bits I mentioned. I've got rid of the constants and the powers of 10. Next bit, a little bit of rearranging. So what have I done here? I've divided through by, well, divided through by 5 to give me a 2. 10 over 5 is 2. And then multiplied both sides by the x squared. So I have a 2x squared, and that's compared to the other side now. Right. So we need to solve for that. You could expand your bracket, take away 2x squared from both sides and get this quadratic equation. You can't factorise that. You have to use your quadratic equation. The answer will come out as minus 0.0828, which is not physically viable. Doesn't make sense, that particular value there. Or 0.4828. That's the answer. This solution, the quadratic equation, doesn't make sense because if x was negative, it would be over here, which would mean the fields were both in the same direction. They wouldn't cancel out. That's not correct. E. In fact, I think I'll stop there and make a part 2 video.